Right triangles. A right triangle is a triangle with at least one 90-degree angle. Anybody remember how many degrees total inside of a triangle? 180 degrees inside of a triangle. So that's always a little bit of a cheat. So you got 90 here. The sum of the other two angles are 90 also. So I'm going to say, for instance, that this side here is 1 meter long. And I'm going to say that this is 30 degrees. So the top of that angle, the top here is what? So this symbol here means 90 degrees. So this one has to be 60. How about we want the length over here of the hypotenuse? The hypotenuse is the angle that's opposite the 90-degree angle. So this angle here, or this length here, we can do that using one of these. And this is shorthand for sine of theta is equal to the opposite over the hypotenuse. This is shorthand for cosine theta is equal to opposite over hypotenuse. And this one is tangent theta is equal to opposite over adjacent.
The cosine wrong.
Oh, thank you. Just wrote the same thing twice, didn't I? Okay. So I asked what the question is what's the length of the hypotenuse? So this is kind of like saying, well, what do we know? We know this angle, and we know this length, and we want to know this one. So you always start these things looking at the angle, theta. So we know theta. We know the side that's opposite to theta. So we know opposite. So we definitely cannot use this one because we don't have an opposite. And we want to know the hypotenuse. This one would be called the adjacent one. There's actually two that are, this is a little confusing, but there's two that are adjacent to you. But one is called the hypotenuse, so it gets the first choice of hypotenuse. The other one is the adjacent one. And the other one is the opposite. So what we're going to have to use, we want to know the hypotenuse and we know the opposite. So if we pick this one here, we know everything but the hypotenuse. So we can go over here and I can write sine of theta is equal to opposite over hypotenuse. And just copy the equation again. So sine of 30 is equal to 1 meter divided by x, our unknown, our hypotenuse. So we can type in 30 degrees, hit the sine button, and then hit the inverse, and we're going to find out that x is equal to 2 meters. This is the special case of a triangle. So this one is 2 meters. Most of y'all have done this before. Has anybody not ever done this before? Probably been a while. Okay. Next, let's figure out the adjacent angle. So if we're going to use this 30 degrees again, which one are we going to use? Okay, Jennifer or Jessica? Jessica. Jonathan. Ezra. Is that all I learned? Did I learn yours already? No, okay. I'm going to try a couple more. What's your name?
Brett.
Okay, Brett. Which equation am I going to do if I'm going to use this 30 degrees and 1 meter to calculate this bottom here? Which one of these things?
Opposite and adjacent, so tangent.
Tangent. Opposite and adjacent. Looks right to me. So I'm going to say tangent of 30 degrees is equal to opposite 1 meter over adjacent.